Good morning, everyone. Good day. Today, I will be discussing the Module 1 or the remaining topics for Module 1. Allow me to share to you my screen. Our topic is all about the measures of central tendency. The measure of central tendency provides a very convenient way of describing a set of scores with a single number that describes the performance of a group. It is also defined as a single value that is used to describe the center of the data. It is thought of as a typical value in a given distribution. There are three commonly used measures of central tendency. These are the mean, median, and mode. In this section, we shall discuss how to compute the value and some of the properties of the mean, median, and mode. First, we have the mean. Mean is the most commonly used measure of the center of data, and it is also referred as the arithmetic average. Here's a computation of the population mean formula. You have this symbol here, mu, equal to the summation of x all over big N, which is equal to x sub 1 plus x sub 2 plus x sub 3 plus so on and so forth up until x sub n all over n. Basically, your capital letter N here, or the uppercase letter N, is the population or the population size. Now we have the computation for the sample mean, which is denoted by x bar, which is equal to summation of x all over n equal to x sub 1 plus x sub 2 plus x sub 3 plus so on and so forth up until x sub n. Supposed to be, it should be the lowercase letter n. Next, we have the computation of the mean for ungrouped data. First formula is x bar equal to the summation of x all over lowercase letter n. Now, if you have frequencies involved, you have x bar equal to the summation of the frequency times your value x, or the data value x, all over the sample size. Now we have an example here. There are scores, or we have the scores of 10 students in mathematics 1 quiz, which consists of 25 items. The highest score is 25 and the lowest score is 10. Here are the scores: 25, 20, 18, 18, 17, 15, 14, 13, 12, and 10. Now, we wish to find for the value of the mean in the following scores. Now you can signify that those scores will be your x's, or your x, or the value of your data value of your data x. So you just add it all up. Okay. Now the summation of x is equal to 162. You need to divide it by n, which is 10, because there are 10 scores, or it means there are 10 students who took the Mathematics 1 quiz. To simplify everything, your x bar, which is the mean of the ungrouped data, is 162 all over 10, which is equal to 16.2. Now, for the analysis part, because in our previous discussion, we have the descriptive statistics and the inferential statistics. For descriptive, we have this solution already, or the computation part. While for the inferential statistics, we need to have an analysis. And the analysis for example number 1 goes like this. The average performance of 10 students who participated in a mathematics quiz consisting of 25 items is 16.2. The implication of this is that students who got scores below 16.2 did not perform well in the said quiz or examination. Otherwise, students who got scores higher than 16.2 performed well in the mathematics quiz compared to the performance of the whole class. Please do remember, whenever we have problems like this, finding for the mean, median, or mode, you need to have the descriptive statistical part and the inferential statistics part, wherein you will solve and compute for the value of the measure of central tendency, and you have the analysis counterpart at the end. Let's move on to the second example. The problem goes like this. Find the GPA or the grade point average of Timmy for the first semester of the school year 2018 to 2019. A table is shown below of the grade or the grades that Timmy got from different subjects. We have the first subject BM112, BM101, AC103N, and BEC111. The following grades are 1.25, 1.00, 1.25, and 1.00, respectively. Please do take note that the subjects or the course subjects that Timmy had consist of units. Each subject has 3 units except for AC103N, which has 6 units. Now we just not simply add the grades and divide it by the number of subjects, which is 4. What you need to do is multiply the grade and the number of units per subject. And we have this last column here. Okay. 3.75, 3.00, 7.5, 3.00, and the remaining subjects. All you need to do is to add all the units earned, which is the summation of the units, which is 26, and the summation of multiplying the grade and the units, which is 32, divided by, okay, the summation of the total number of units, which is 26. You have the mean for the group data already. Or I mean ungrouped data still, but with frequency or the units earned per subject. That is 32 divided by 26. Rough estimation is your X bar or your mean is equal to 1.23. Analysis will be the grade point average of Timmy for the first semester of school year 2018-2019 is 1.23. Furthermore, Timmy's scores higher than 1.23 means that he performed well in those subjects, while subjects that has or have grades lower than 1.25 means that Timmy needs to give more time and effort in those subjects. Now, we already have solved for the mean for the ungrouped data. On the other hand, we have what we call grouped data. These are the data or scores that are arranged in a frequency distribution. What is a frequency distribution? When we say frequency distribution, it is the arrangement of scores according to a category of classes, including the frequency. When we say frequency, it is a number of observations falling in a category. Now, in order to find for the mean of a grouped data, we will use the midpoint method. Okay? We have a formula for that one. Summation of f times the x sub n all over the sample size lowercase letter n. Of course, your f there is the frequency in each class or category. Your x sub m is the midpoint of each class or category. Now, here are the steps. First, we need to find for the midpoint of each class or category. You can do that by adding the lower limit to the upper limit, and you just divide it by 2. Lower limit is the smallest value for each class. So for example, in number 3, we have this lower limit 10 for the first class, 15, 20, 25, 30, 35, 40, 45, 50 will be the lower class limits for each interval, and the upper limit or the upper limits will be the otherwise 14, 19, 24, 29, 34, 39, 44, 49, and 54. Once you got the midpoint of each class or category, you need to multiply the frequency to the corresponding midpoint, or this is what we call the class mark. So in symbols, that is f times x sub m. Next, you just add all the products that you got from step number 2, or in other words, the summation of f times x sub m. Lastly, you will just substitute the values in the formula. X bar is equal to the summation of f times x sub m all over n. So here's the computation, or here are the computations, substitutions, in finding the mean of the grouped data. By the way, your example here, we have the scores of 40 students, which is categorized, okay, by a class interval size of 5. Again, it is a 60 item assessment. Of course, the highest will be 54, the lowest will be 10. So we have the summation of your f times the class mark, or the frequency times the class mark. Summation of that one is 1,345 all over the sample size n, which is equal to 40. How did we get 40? We just add all the frequencies. That will be the sample mean size, our sample size. So dividing 1,345 by 40, you have approximately 33.63 as your mean for this grouped data. Analysis is the mean performance of 40 students in science quiz is 33.63. Now, those students who got scores below did not perform well, while those students who got scores above 33.63 performed well. Now, here are the properties of the mean. First, it measures stability. Mean is the most stable among other measures of central tendency because of every score distribution or every score contributes to the value of the mean. Next, sum of each score's distance from the mean is 0. It is easily affected by the extreme scores. It may not be an actual score in the distribution. It can be applied to interval level of measurement. It is very easy to compute. And when do we use the mean? Sampling stability is desired. Other measures are to be computed such as standard deviation, coefficient of variation, and skewness as well. The second measure of central tendency is the median. Again, it refers to the centermost score when the scores in the distribution are arranged according to magnitude. When we say magnitude, it could be from highest to lowest score or vice versa. Lowest score to highest score. Of course, median of the ungrouped data, you just simply arrange the scores from either highest to lowest or lowest to highest. You can determine the middlemost score in a distribution if n is an odd number and get the average of the two middlemost score if n is an even number. For example, the median score of 7 students in an English class are 19, 17, 16, 15, 10, 5, and 2. It is already arranged from highest to lowest. You just get the middle term, which is, okay, 15. Analysis. The median score is 15, which means 50% or 3 of the scores are above 15, and 50% or 3 scores below are below 15. Namely, for the scores above, we have 19, 17, 16, scores below 10, 5, 2, respectively. Another example, median score of 8 students in English class, 13, 19, 17, 16, 15, 10, 5, and 2. Please do take note that there are 8 students, even number of values or data values. So it means that you get the values between two data values, and that is 16 and 15. You get simply the average of the two, that is 16 plus 15 all over 2. So x tilde or tilde, this symbol here is tilde. Okay, x tilde is equal to 15.5. That is your median score. Please do take note that the median can be found among the data set of values, or it could not, especially in the even number of dataset values. Analysis 15.5, which means that 50% of the scores are lower than 15.5, namely 15, 10, 5, 2, and 50% are greater than 15.5, namely 13, 19, 17, and 16, which means 4 scores are below 15.5 and 4 scores are above 15.5. Now, how about the median of group data? Here is the formula. X tilde is equal to the lower class boundary plus, okay, quantity of n over 2 minus CFP all over FM times the class interval. You have this legend here. CFP is the cumulative frequency before the median class. FM, frequency of the median class. CI, size of the class interval. LB, lower boundary. When we say lower boundary or upper boundary, you go back to the limits. For example, here, 10 is the lower limit, 14 is the upper limit. Lower class boundary, you just subtract 0.5 to 10. Upper class boundary, you just add 14.5 or 14 with 0.5. Steps in solving, complete the table for the cumulative frequency less than. Get n over 2 of the scores in the distribution so that you can identify the median class. Determine the lower class boundary, the cumulative frequency of the previous group, and the frequency of the median class and the class interval, and use the formula. Going back to the formula, the word boundary n over 2 minus CFP all over the frequency of the median class times class interval. You have an example here, 40 students consists of 60 items. Again, we have the same example there earlier. Okay, you just add another column for the cumulative frequency less than. What you do is you copy the first frequency here. Next, you add the succeeding frequency, which is 2. 5 plus 2 is 7. So on and so forth, up until the last one. Please do take note, the last cumulative frequency less than will be equal to your sample size or population size. N over 2, because that is the second step, in order to find where is the median class. So 40 over 2 is 20. If you come to take a look at it among the CFP, okay, in the fourth interval, it is only up until 15. Fifth interval and sixth, okay, which means that if you have 17 here, 17 or the 17th data set is located here, and the next group is, it started with the 26th data set value. It means that your 20th data set value is in this interval, the fifth interval, from 30 to 34. Okay, so we have n over 2 is 35. Find or 35 to 39. Okay, so again, sorry for that one. This will be your median class.